Alright, welcome back. It's Chili here, and this is lesson 5 of the intermediate series. We're going to talk about, let me just get rid of this here. Get rid of this. Here we go. We're going to talk about Windows. The Win32, Win API part of the framework. So this is the second part of the two-part series on the framework. Last series we talked about Direct3D, and this one we're going to talk about Windows and the keyboard, possibly the mouse, and that'll be it. I mean, the game, that's it's pretty self-explanatory. I guess I'll go over it a little bit in this lesson too, but mostly this is going to be all about Windows, Win API. So this will be a little different than the last one. In the last episode, I did a lot of background about graphics technology. I took you guys through the history. We're not going to do that with Windows because, quite frankly, it's not that important. It's one of those things where you code it in the beginning to get your program up off the ground, and then after that, you just forget about it. Because most of what we're going to be doing is just with DirectX and some other stuff, so yeah, it's not that important, but then again, you can't have your program without dipping a little bit into the Windows inkwell, so you need to know it, but you don't need to know it like the back of your hand, I guess is what I'm trying to say. So, where should we start? Basically, Windows, it's fueled by three things. It's fueled by Windows, right? What I mean by that is in Windows, everything is a window. You may not realize this, but I mean, if you have your application, you consider this a window. But all these buttons here, all these sub-windows here, buttons, controls, text boxes, everything in Windows is a window, is what I'm trying to say. It depends on the application, but in standard dialog boxes, like let's say I go, I don't know, open a file. Okay? So this text box here, this label, buttons here, list boxes, and so forth. These are all windows. Everything in Windows is a window. But luckily, we don't have to worry about that shit. All we need for our game is our one main window, and then everything else we control ourselves. We don't let Windows manage shit for us. But if you were going to write an application, an actual productivity application in Win API, which is a bad idea, by the way, yeah, you would be making multiple windows, child windows with controls, like text boxes and stuff, which are also windows. Yeah, but Windows. It's all about the windows, and it's all about messages. So how Windows communicate with each other, how the operating system communicates with Windows, how it informs your application about events, such as when the mouse is moved, or when a button is clicked, or when a keyboard is pressed. It's all communicated with messages. So Windows is about Windows, messages, and it's also fueled by pure hatred. Yeah. But I won't explain that part. I'm sure you guys can figure it out. So, how to explain this crap? The basic flow of a Windows program is we're going to limit our discussion to a Windows game application program, okay? In the framework, the flow goes like this. You create your window, and after you create your window, you handle messages, and run your game.go. Basically, you run your game function, which in the framework is Go. So you have to have a loop. This is a loop here. It's a while loop, right? And you continually check for new messages from Windows, like button presses or keyboard, mouse moves and stuff like that. And if you have any of those messages, you handle them. And you also run the game loop. And every time you run game.go, the game will draw a frame on the screen. And that's basically how most simple game programs work in terms of Windows. You create a window, and then you handle messages, and you handle your game code. Now the trick is, first of all, how you create your window, and second of all, how you handle the messages. And that's what I'm going to be talking about today. So, there are two parts to creating your window. The first part is you have to register a class of the window, which is like, it's kind of similar to classes in C++. It's a template, a cookie cutter, if you will, that forms the basis for making actual instances of a window. So you can register a class which describes the type of window, and then you can create one or more windows that belong to that type or that class. So here we have a structure, wind class EX, and it describes the attributes of a class of windows. And it has a bunch of members. I'm just going to show you the members here. I'm not going to explain them all because they're not that important. But let's see what we have here. I don't know what that is. Size is the size of the structure. So it has to know its own size. And you just do size of wind class EX and you put it in there. What else we have? CS class DC. Maybe I should look this shit up. See, I don't really know the order of the members of this class. I guess I could look this bullshit up. Go to definition. And it's defined as class EXW. Go to definition. Class EXW. So here is our Windows class here. Starts from here to here. So it is size, style, all this stuff here. Interesting, it has a comment here that shows you what parts are from Windows 3X and what parts come from Windows 4. A lot of this shit, a lot of this Win API, this stuff goes way back into the days of like Windows 3.11 or whatever, where you were like basically a shell running over top of DOS. I mean, even Windows 98 was running over top of DOS, right? But yeah, a lot of this is pretty legacy shit. So what do we have? We have the size of the structure. We have the style of the window. Here is a long pointer to a function. And I'll get to that later. But this is why I taught you guys pointers to functions in lesson 3, I think it was. Class extra, wind extra. I have no fucking idea what those are for. H instance. That is a handle which refers to the instance of the program, I believe. Handle to the icon. That is the icon that will be used to display the window. So it'll be used down in the taskbar and in the top left-hand corner. Handle to a cursor. That's a handle to a cursor resource type. you know, the mouse pointer. Handle to a brush for the background, which is the default brush used to draw the background of your window. But we never use that because we're drawing it with DirectX. We don't use brushes and stuff like that. They work with GDI, which is a different graphics API. And it's much slower than DirectX. But it's often used to draw the screen in applications like word processors and shit like that. Here's a string, which is the name of the menu, which I guess would be used for the Windows menu, like something like this here. And last is the name of the class. And here we have H icon small, which is another handle for an icon, but it's a smaller version of the icon. Alright. So, yeah, I don't really know what this one is for. But if we look in the Windows, where is it? 1, 2, message proc, and then 0, 0. So those two things that I had no idea about, that is these two things here, which are just set to 0. They obviously have a meaning, but it's not useful for us making a game thing, I don't think. I could look it up, but I'll just take more time. So if you really want to look it up, I mean, if you want to look any of this shit up, you can do it. I mean, you just go wind class EX, copy that shit. You just open up your trusty browser, and you take that mother to Google. You know the drill. Paste that in there. Wind class EX structure. And then you wait forever for fucking Windows Dev Center to load up. And then you got a list of all these happy parameters and what they do. Wind class extra, the number of extra bytes to allocate following the window class structure. So this allows you to allocate extra bytes to store whatever kind of data that you want to store. It's like, you're never going to use that, trust me. And CB wind extra, number of extra bytes to allocate following window instance. Interesting. So this is extra bytes for the window class structure, the template or the cookie cutter. And this is extra bytes to follow every Windows instance. So this will help you store extra information at the Windows side that you can use. It's not, you're never going to use this shit. So, I mean, if you get to the point where you can use this, then you'll be able to understand it. But this will just fucking confuse you, man. So don't worry about it. You'll never need that. And yeah, menu name, null terminated character string that specifies the resource name of the class menu. Yeah, so you can have a separate resource that is the menu, and if you put the name here, it'll load that resource for you. So the menu can be stored as a resource in the executable, just like icons and shit. And if you give the name, it will load it for you automatically whenever you instantiate a window from that Windows class. So, Wind class EX. Why are you doing... Oh, okay. Because I put this thing here. There we go. You define a Windows class. It's a very simple Windows class. I don't know. What is CS class DC? Just for my own... Because, I mean, I wrote this code, like, way back, and I don't remember this shit. Because, you know, you write it once and you just forget about it. What? Pissing me off, brah. I am going to go back to Google now. And I'm going to freaking... Fuck you! I'm going to copy this. And then I'm going to paste it here. Search that. What does the CS class DC say about Windows classes? This one. This one looks like it'll be helpful. CS class DC allocates one device context to be shared by all windows in the class. Shut up. Because window classes are process specific, it is possible for multiple threads of an application to create a window of the same class. When this happens, the device allows only one. Interesting. So if you instantiate multiple windows of this class, it will make them share a single device context, which is just a thing that's used by GDI to draw shit. Interesting. I don't know why you'd want to put this in there, but apparently that's what you put in here. What would happen if I did something different here? What would happen if I, wait, did I fucking close that window? I fucking closed it, didn't I? Fuck me in the eye with a fork. Let's see if I put something else here, like no close, class DC, parent DC, own DC. What happens if I change it to own DC? Will that break my program? I don't think it will, but I don't know. What do I know? Let's try it. Let's try that. What's your problem? What's your problem, brah? Why did I put a breakpoint here? I don't even know. Well, it seems to be working. Let's try. Fucker. There. And where's my 0? There it is. Should turn on the light in here. I want 2, 1, 6, whatever. 2. Fuck, I can't do 66. That's no good. 255. 255. Okay. Let's draw this mother. And yeah, it works. So fun. Own DC, and it worked fine. But what I imagine is that class DC is maybe simpler. I don't know, because you're only making one instance of this class. You're only instantiating one window based on this class. It doesn't matter whether every instance has its own device context or whether they all have different device context. And I mean, I'm not even sure how important device contexts are because we're drawing everything with DirectX. So yeah, whatever. I'll just leave it class DC. I probably just found it like that in like one of the Microsoft examples, and I just copied it because I didn't find any reason to change it. Message proc, we'll get to that later, but that is this. That's this function. That's a pointer to this function, right? Because if you put the name of a function without the brackets behind it, it's a pointer to that function. So we're passing it a pointer to this function, which is very important and will be used to handle the messages. This is that byte allocation shit. This H instance thing here, this get module handle returns the handle to the current instance. And it's like a thing used to refer to a program that's running on Windows. I don't really have any different way to explain that. It's not some Windows functions require you to tell the instance of the program when you're calling it, and you got to get your handle to your instance and do it. And I don't know what to say. And a bunch of other shit that it's not important. We just set all these things to null because they're not important, right? Like one of these is for the menu, right? And one of them is for other stuff. I've already forgotten. I closed that window. But yeah, we just got to define our Windows class here. And one thing that we do define for the Windows class, I think some of these in here are null, but later I set them, for example, for the loading the icon and the small icon. And there's a function called load image, and that'll load an icon from the resource that's in the application. See this thing here? Chili DirectX framework.res. That is a compiled resource. It contains the icons that are used for this program. So it contains the chili icon So when you run the program, you see the chili icon in the taskbar. That is actually in this resource. And this load image, well, first when you compile the program, it sticks those images into the executable itself. And to get them out again when you're running, you have to call load image. And you call h_instance to say you want to load it from the current instance. Right. And then you do this thing, which takes this integer value, which is the identifier for the icon, and it does some magic and it turns it into something that the load image the load image function can use. And then you tell it the kind of thing you want it to load, image icon, and you tell it the dimensions of the icon, and you tell it 0. I forget what the 0 is. Undo. What? Fuck you. I said undo, brah. Okay, what's the 0? Foo load. That tells me nothing. I have no idea. It means something. If you want to know, look it up. Fucking look it up. Fucking Google that shit, man. It's not important. So you do all this. You set up your descriptor for the Windows class, what kind of a class it is, and then you register that class with Windows. You pass this structure to Windows, and Windows will register. It has a list of different classes of Windows, and it will stick your class into that list of classes that can be used to create actual Windows, to instantiate Windows. So once we've registered our custom Windows class, then we can create a window using that class. So first thing we do is we create a rectangle structure that will describe the positions of the corners of our window. So the left-hand side is 100, the right-hand side is left-hand side plus 800, right? So that'll give us a width of 800. And the top is 100, and we got 600 plus the top, which will give us a height of 600. 600 by 800. This is where the size of our window is actually determined. Then we call something called adjust window rect. So we give this size, but we don't want this size for the entire window. You got to remember, you got to know something. You got to learn something. You got to listen to me. Listen to Chile. He's going to tell you something. A window can be divided roughly into two sections. You have the client section, which is a section where shit is actually being drawn. That's the part where all the action happens. That's called the client area of the window. The client region. I think it's like client region or client area, whatever. That's the client part of the window. And then you have the non-client part, and that's the part that is it's like common to most windows. So it's this it's the title bar. It's these buttons here. It's this border. That's the non-client part. So we want the client part of our window to be 800 by 600. But we have to factor in the non-client part to get the final size of our window. So we call adjust window rectangle, and we tell it the style of our window. And based on our desired client size and the style, it will adjust this rectangle so that it gives us the size of the entire window. The size of the entire window that we need to get that client size, the desired client size. So let me just show you guys how this works. I'll set a breakpoint, and so here I set my Windows rectangle. I got it in hexadecimal mode. There. So here I set up my rectangle, right? 100, 100. The top is 100, bottom is 700, left is 100, right is 900, right? Now watch what happens after I call adjust window rect. See what happens. You see the top and the bottom, the left and the right, they've been actually moved. They've been adjusted. So they've been adjusted so that the client part will be 100, 100, 900, 700. So it adjusts the actual dimensions of the window so that the client part will be what I specified here. And that's why it's called adjust window rect, because it adjusts it to give us the desired client. It's much easier than trying to calculate that shit yourself. And yeah, it's kind of complicated. If you change this, there's rules. It doesn't work with all the window styles, so it's kind of fucked up. But whatever. Yeah, so that's what that does. And once we have our desired rectangle for our window, then we create a window. So what we do is first of all, you identify the class that you want to use to create your window by a string. It doesn't use a pointer or a handle, it uses a string. So this string has to match this string, otherwise it won't work. So you tell the name of the class that you want to create, the window class you want to use to create your window. Then you tell another string, which is the title of the window. So this is just text that the user sees, but this is actually used in the function to choose the class. This is just aesthetic, and this is actually functional. So yeah, you pass it the class name, then you pass it this text you want in the title bar of the window. Then you pass it the type of the window that you want to create, which I find kind of strange, because I would think you would put the type of window in the class, but for some reason the type of the window, you pass it in create window. This is an overlapped window, which has overlapped window means it has like a border and like a title bar. I fucking don't know all the different things. I could look it up, but do you really want me to do that? It'll take time. Anyways, then you pass the dimensions or the positions of the top left corner and the width and the height. So you put the top left corner here, and then you put the width and the height. Then you got some other shit here which I forget. The parent window, but since this is the main window, it's top level window, it has no parent. It is an orphan, and handle to the menu for the window. Which is strange because you also put menu in here, but whatever. This window doesn't have a menu, so we just put it null. And again, you gotta pass it a handle of a instance. You pass it the handle of the instance of the current module, and the last thing you pass it is a special parameter that will be used later on, but we don't use that parameter, so it's just null. And by doing this, you create your window. There you go, you have it made. So I mean, if I put a breakpoint here, I run this mother. Wait. I said a breakpoint. Why isn't it breaking? Now I'm pissed off. You're supposed to break here, brah. There we go, we broke. I guess I must have clicked the wrong button. So if I step over this, well, it created our window, but now I have to go through here to show the window. See, once I call the show window function, it actually shows the created window. So when you create a window, it defaults as being hidden, and you have to show it to make it actually appear on the screen. And then we go update window. Fuck, I pressed the wrong button. Motherfucker. There we go. So I go show window and it shows up, and then I go update window and nothing happens. Actually, I don't even think update window is needed in this case. What if I delete this mother and try it again? There we go. Yeah, see, look, it works fine without update window. Or maybe it doesn't, because I can't actually click this mother. Well, wait, it's working now. Yeah, it's working fine. Fine and dandy. So we probably don't even need update window here. Let's try that again. I just put it in there because I don't know. I thought maybe it was necessary. But apparently show window by itself is all you need. If you don't call show window, I'm pretty sure that you're not going to see your window. Yeah, see, I just ran the program and my window didn't show up. See, just nothing happens. So you need to call show window to make your window show up. That's good to know. And now it's saying that there were errors. Oh yeah, I bet you I know what the error is. Cannot open the program, right? Because I ran the program and it didn't show up. I didn't have a way to delete it, so that program is still sitting in memory here. Start task manager. I hope that didn't like fuck up my recording there, because I had to go to the task manager thing. Okay, so I gotta end this process. You gotta go, Chili. And is there another one? Because I have the distinct feeling that I ran it a few times. In that process, obviously if the process is still running, it can't be, the compiler can't overwrite it. It can't replace the exe with the newly built one. So now I build and it's fine. And I can run and my window shows up and I can close it and that's good. So after you create a window, you got to show that window. Common newbie mistake. And after I'm done showing the window, so I've registered my class, I've created my window, I've shown my window, now I create my game object. And what the game object does, this has nothing to do with Windows, but it takes one parameter. It needs one Windows parameter, and it needs the handle to the window. I think I've explained this before, but a handle it's kind of like a pointer, but it's not a real pointer. It doesn't point to somewhere in memory. It's just like a name that the computer uses to refer to something. So it's a name. It's kind of like a name of a window. So we have to pass it the name of, or the handle, to our current window, because if we go to game.cpp, game includes graphics and it includes a keyboard object. And the graphics object, the constructor for our graphics object, needs the handle to the window. Because if you remember from the other lesson, when you create your device, you need a handle to the window to create the device. And the device actually chooses the size of the back buffer based on the size of the window. And it needs the handle to the window because it needs to know where to put the back buffer when you present, right? When you call, where is it? When you call device pointer to present, it takes the back buffer and it copies it to the client region of our window. So it needs to know the window to copy shit to, and it needs to know the window to get the size of the back buffer. So you need the handle of you need that hwind to create your device. And that is one of the main reasons why we do all this shit, just to get this hwind. And that's what create window returns. When we call create window, it creates the window and on the Windows side, and it returns us a handle to that window. So whenever we want to do something that involves that window, we refer to it with the handle. If we want to show the window, we call it with the handle, saying show that window. And if we want to create a DirectX device, we need to create it using the window handle. So we create our game object here. And we pass the handle to the window, and we pass it the keyboard server. We pass that by reference actually, but I'll get to that later. Then we come to the message loop. This is the most important part of the Win API part of the code. So what we do is we create a message structure, and a message structure has a bunch of members. It has the handle to the window that the message is for. It has two parameters, an L parameter and a W parameter. It has message, which is the type of message that is passed. It has a point, which I guess refers to the point at which the message happened, if it's like a mouse click or something. And we have a timestamp, which is the time that the message occurred. And these messages are used. That's how Windows communicates with our window. It passes it messages, and we process those messages. So we have a loop here called the message loop. And what we do in this message loop is the first thing we do, well, we initialize our message to 0. So we zero it out, we clear out our message. And we keep looping while the message code for the message is not quit. So if a quit message is ever read out of our message queue, we immediately exit this loop and we unregister our class that we registered up here, just cleaning up, and then we exit the program. So when we zero out the message, it's not going to be quit. It's just going to be a null message. So that means we enter the while loop. And the first thing we do when we enter the message loop is we call peak message. And what peak message does is it does two things. First, it checks if there is a message waiting for our window. In the message queue, there's a queue of messages, and it checks to see if there's a message in the queue. If there is no message, it returns false, and we process our game frame. We go to the game and we call .go, and we run a single frame of our game. But if there is a message, then we remove that message. So we copy that message onto our message structure here. See, we pass a pointer to this structure. So we use the address of message. We pass a pointer to our message structure. And we tell peak message that if there is a message, remove that message from the queue and copy it onto our message structure here. And then we translate the message and we dispatch the message. Translate message, don't worry about this. It's not something you need to know about. It just basically does some processing on the message for us. And dispatch message, that sends the message to our message procedure, which then handles the message. So, yeah. Now, you might be wondering, how does it know to send it to this thing? Well, when we registered our Windows class, we gave it a pointer to this function. So whenever we call dispatch message, it will look up the Windows class. It'll look up which function is supposed to handle messages for this class, and it will pass the message on to this function for us. So the flow is like this. We check for a message. If we have a message, we remove it from the queue. We translate it. We do some pre-processing on it. And then we dispatch it. And it goes to this function. And in this function, we handle the messages. And the way we handle it is we do it with a switch. So we... where is this? So this message thing is the message code. The message code. And we switch the message code. And depending on what kind of message code it is, we do some processing. So if the message code is destroy, then we call post quit message, which just posts the WM quit to our message queue. And when we post that message, then the next peak message will read it'll read quit, and this while loop will exit, and the program will end. So if we get a destroy message, we want to quit. If we get a key down message, then we want to switch this W parameter. So W param and L param, the values that they hold depend on the message. So for the key down message, the W param holds the code of the key that was pressed. So when we get a key down message, we have to check the W param, and depending on what value that parameter has, we can determine what button has been pressed. So we switch on the W param to determine which key was pressed, and if it was any of the keys that we're interested in, then we do something. In this case, we call on our keyboard server, we call the function that will update the status of the server to reflect what keys have been pressed. So on key down, if the up key was pressed, then we call kserve.onUpPressed. Likewise, if the key up message is received, we switch on wparam, and if one of the keys that we're interested in was pressed, we call kserve.onButtonReleased. And that's basically how message procedures work. Now, there are a lot of messages that are passed to a window when it has to, whenever shit happens. There's lots of events that can happen, and they all have their own messages that can be passed to the window. But you only have to handle the ones that you're interested in, the ones that you need to define the behavior. And for the other messages, what you can do is you can fall back to the default Windows message processing behavior. So there's a function called def window proc. It's the default Windows procedure. And what we do is, for any messages that we don't handle completely, we call default Windows procedure, and we pass the message on to the default procedure, and it will do some default behavior for us. And it will handle a bunch of behavior that we don't want to worry about. So, for example, in the case of WM destroy, we just return immediately. So we don't even call the default Windows procedure. We handle this message completely ourselves. But for the key down messages, what we do is we break, and then we pass it on to the default Windows procedure. So we handle the message, but then we also pass it on to the default to do some additional handling for the button presses. And that will, I don't know, that might help for certain buttons. I'm not even sure if the default Windows procedure, if it does anything for key up or key down. But just in case if there's something to handle, I call the default Windows procedure, so it will be handled by the default behavior. And for all the other messages that are not processed in our switch here, they just all go to default window procedure. So yeah. And that basically is how the Windows system works. So let me draw you a picture, because that was a lot of stuff to learn. Let me see here. Control A, delete this if I can find my delete key by blindly feeling around my keyboard. Control D to deselect. So in our program, we can divide our program into two parts. My fucking God damn it. 1 second. I gotta do something here. Map this mother. Portion. Define area from here-ish to here-ish. Okay. That should be better. Yes, good. Okay. So this is the user side, the side that we handle, and this is the Windows side. So the first thing we do when we're running a Windows program, I'll call this the timeline here. This is the timeline. First thing we do is we register. We register our class. And when we register the class, Windows will create a class here, our class. So it has a list of classes, a bunch of different classes, and it will add our class to that list. So we register our class. Then we call create window. And what it does is, based on our register class, it will create, like a window and shit, just for us. And that looks really retarded. I wanted this to have the effect of being like a Windows title bar. You got like this thing here, you got the minimize button here, right? And you got like window. That's our window title, window. So when we call create, it uses our class as a template to actually instantiate a real instance of our window, and it gives us back a handle to this window. And now we have our window, and we can use this handle in our show function, and that will show the window on the screen. And then what we do is we use this handle. See, for our window, Windows stores a message queue. And whenever something happens, like for example, user presses a key, it will add a new message to the queue. Wait. One Windows message key down or something like that. And when we call, whoa, there's way too many S's. When we call peak message with our hwind, it checks the message queue, and if there is a message there, it will erase that message and put it in our message structure. And then we call translate to do some translation on the message. You don't have to worry about what kind of translation it is right now. You can look it up if you want, but it's not that important. And then we call dispatch. And what dispatch will do is it'll look at our class here. And inside our class, there's like a bunch of different parameters. And one of those is the pointer to the window procedure. So we had a window procedure in our user code, windproc here, and it checks the pointer to the window procedure, and it takes the message, it takes our happy message that was passed to dispatch, and it routes it over to the window procedure. And in the window procedure, we process the message, and then we call the default window procedure, which is actually a function on the Windows side, right? That's the default behavior, and it routes the message to here on the Windows side, which does any additional processing. Then it comes back here, and then we return to here, and we try to peek for another message and remove another message from the queue, dispatch it to our Windows procedure, then we call the default, and we come back. And if there's no messages left, then we call game.go. And that's how it is. Doesn't get much simpler than that, does it? Ha ha ha. Alright. So that's basically how Windows works. And yeah. If you want to handle some new kind of things, like if you want to, for example, handle mouse input, then you just add a new case thing here for a mouse message. But before we do that, I just want to what do I want to do? I want to explain how the keyboard server works. The keyboard system. So, how are we going to do this? Photoshop. Maximize. No, I didn't want to do that. There we go. That's what I wanted to do. I could add a new layer here. I could hide this layer. That kind of sucks. Control All. Delete this. Where's my delete key? That didn't work. Okay. Then what we're going to do is we're going to fill it. Fill. That's not the fill button. Dr. Phil. Hate that guy. That was the wrong color, brah. Damn. Right click doesn't work. Fill that. Alright, done. Make another layer on top of that layer. There we go. Okay. So, here's the deal. Here's the skinny. So I have an object, or I have a class called game. And I want it to include an object, an embedded object of the type keyboard. And this object is what the game class is going to use to basically learn about how the user is interacting with the keyboard. So this class here will inform the game object about keyboard events, or the state of the keyboard. So it's inside the game object. But at the same time, the keyboard object has to learn about what buttons are being pressed through the message procedure. So the message procedure has to be able to call a function of our keyboard object, like for example on up pressed or whatever, on down pressed. It has to be able to call those functions to tell the keyboard object that this button has been pressed. So it has to update its internal state. But there's a problem with that. See, if my game is declared in here, it's not visible to this function. These two functions are different scopes. So this function can't access, it's not aware of my game object. So how do I solve that? Well, one way to solve it would be to declare the game object as a global variable. So if I declared it globally up here, then both the message procedure and the Windows procedure could access it. However, there's a problem in that the game object needs a handle to the window in order to be constructed, because the game object also has an embedded graphics object. So it needs the handle to the window. But if you put it global, it will be constructed at the very beginning of the program, and we won't have had time to create our window. So you can't construct your game on the global scope. So the solution is, well, one solution is, instead of embedding the keyboard inside the game object, you could just have something like a keyboard pointer or a keyboard reference. And it would point to a keyboard object that is outside of the game object. So then you can create your keyboard object globally, and it can be accessed by the Windows procedure. But you can also then, when you create the game, pass it a pointer or a reference to the keyboard object, and then the game can also access the keyboard object via its pointer. So it has a pointer here and it accesses the keyboard object after it's created. And that is the situation that I have opted to do. But I took it one step further. So think about it this way. If you had a keyboard object, it's going to have functions for on. Basically, when a button is pressed, it'll have a function to set the keyboard state for pressing. And when a button is released, it'll have another function to release the button. And there'll be a third function type, which is pressed. And that's the function to check the state of the keys. And what you have is the game is going to be checking the state of the keys. The game wants to learn about the state of the keyboard. But the Windows procedure is only going to be calling the press and the release, because the Windows procedure is basically updating the keyboard object, whereas the game is just getting information from the keyboard object. It's polling the keyboard object. Now, with this layout here, basically all of these functions have to be public, because the Windows procedure has to access this stuff here and the game has to access this stuff here. But the game could end up accessing these functions, which doesn't make any sense, because the flow of information is the Windows procedure. There's a message. It goes to the Windows procedure. The Windows procedure sends the information to the keyboard object, and that information then flows from the keyboard object to the game object when the game object calls this function. So it's a flow of information from here to here. But you could have some idiot try to call our onPress function from the game object, which is backwards information flow, and that breaks our paradigm. So to make the game, to make the coding and the architecture of the system cleaner, we would like to restrict the Windows procedure so it can only call these functions, and we want to restrict the game so it can only call these kind of functions, the isPressed functions. So we want to segregate this object. We want to kind of divide it into two. And the way we do that is I divided it into two separate objects. I call one the keyboard, Control Z, keyboard client, and the other one the keyboard server. And these are two separate classes, so they form two separate objects in our program, but they're very closely related. They fit together like pieces of a puzzle. And the keyboard client contains the is pressed, and the keyboard server contains the on press and on release functions, and the Windows procedure calls these ones. This one, the keyboard server, is global, and the keyboard client is actually embedded. The game doesn't have a pointer to the client. The game actually embeds the client inside of itself. So we have keyboard client, and that's this thing here. So it's embedded in our game object. And the keyboard client in the private here, it contains a reference to the keyboard server. It's a reference, and that points to the server. So in other words, that's in here, right? Keyboard server reference, and that's pointing to this thing. So we separate the single keyboard class into two different classes, a client and a server. We make the server global here, so it can be accessed by the message procedure, and we pass the server to the game when we start up, and in the game constructor, the server is passed as a constant reference. So it's a reference, and we're not allowed to change the object that's being referred to. And that constant reference is passed on to the keyboard object. And if we go to keyboard.cpp and we go keyboard client, the server member is just a reference to a keyboard server. And we use the past reference to initialize the reference here. So if we look at keyboard.h, we have a keyboard client, and it has a bunch of functions, and it has one private data member, which is just a reference to a server. So it points to or it refers to a server. And that way these two are linked. And in the server, we have all the functions for updating the state of the keys, and we have the values of all the keys that are private. And there's one thing in here that I don't know if I covered this in those tutorials, but I made it because basically the keyboard client and the keyboard server are one class that have been split into two. So what we can do is we can say that the keyboard client is a friend of the keyboard server. And what that means is that the keyboard client's functions here, they can access the private data of the keyboard server because it's a friend. Now normally this is bad. You don't want to make all your classes friends of each other, because then they can access all their private data members and things get hairy very quickly. But the one situation in which it's okay to make friends with classes is if it's fundamentally a single class that's been divided into two parts. And this is one of those situations. So normally you should avoid the friend keyword, but in this case it's perfect. And it allows this function here, for example, up is pressed. If we look at it in keyboard.cpp, up is pressed, it accesses the reference, and it accesses the Boolean value here, which is a private member variable. But because it's a friend, it's allowed to access that private member variable. So we have some, here we have some private bool up is pressed, and is pressed uses this reference to access this variable, and it's allowed to do that because it's a friend. So our keyboard client, our server considers our client as a friend, so the client can access the private variable here and pass its contents onto the game. But because the game only has embedded a client object here, it only embeds this object, it cannot access any of these variables here, or any of these functions here. Only the window procedure side can access them. So we divide a single object into two parts, and by that we can restrict what functions the different parts of our program can access. And we give a very clean interface into our keyboard from both sides. And that's the kind of paradigm that I use for input under Windows 32. That's how I get the data from the Windows procedure to our game object. So again, like I was saying, our game object embeds a client, and that client contains a reference to the server, and the client is allowed to access the data of the server because it's a friend. But the game object is not allowed to access the server directly. It has to go through the client. And that is how that works. The last thing I want to show you guys, I'm going to have to open up a different project because it's not in this one. Yeah, I'll save changes, whatever. The last thing is what? What in the butt? What do I want to show you guys? Pooh? Tic-tac-toe? I guess any one of these will be fine. I'm going to show you Pooh Face EX plus alpha. Okay, so yeah, that's basically everything else we had before. Let's go to the mouse. So I added the mouse later on. It wasn't part of the original framework. And it follows the same, basically the same design pattern as the keyboard. You have a server and a client. And the server, wait, let me get to my windows.cpp. The server is declared globally here. We got the mouse server. I make it static so you can't access this server from any of the other modules. So you can't access the global mouse server from game.cpp because it's static. I also explained this stuff in that tutorial. Tutorial 3, I think. But it's global, at least with respect to this translation unit, windows.cpp. And it's accessed whenever we get a Windows, we get mouse messages. So there are a few messages you can get for the mouse. You can get a move message, which is whenever the mouse moves inside the client area of our window. And we can also get messages for the mouse buttons, button up, button down. And we handle the mouse messages, and based on how we process it, we call functions on the mouse server. So the mouse server has a bunch of functions. On mouse move will update the position. On mouse leave will update whether the mouse is in the window or whether it's outside the window. And the button pressed messages will update the state of the mouse buttons. There's also a function here to check whether the mouse is in the window or not. And we have a bunch of data for the mouse. We have the X and Y position of the cursor, and the state of the left and the right button, and a Boolean that keeps track of whether the mouse is in the window or whether it has left the window. And again, the server contains a reference. It only contains a single data variable, which is a reference to the the client. I meant to say the client. The client only contains a single data member, which is a reference to the server. And its functions are all about getting the state of the server. So get the X and Y, get the state of the buttons, and check to see whether this is in the window or not. And what else? So how you process the where is it? Windows, here it is. How you process the mouse messages, I mean, it's very simple for button presses. It's the same as for keyboard press, right? If the mouse button is pressed, call the server, the corresponding server function. So if the left button down message comes, call on left pressed, right? But it's a little trickier for calculating mouse coordinates. So on mouse move, first you have to get the X and the Y. And the X and the Y coordinates are actually they're packed into the L param. So the L param contains the coordinate of the mouse, but they pack two 16-bit values into the 32-bit L param variable. So you have to extract the low word or the low 16 bits, which is X, and the high word or the high 16-bit, which is Y. It's just basically bit shifting. So I mean, if you look at high word, if you go to definition, you'll see it's just 16-bit shifting, and then it's ANDing, so it's masking. Shift and mask is all it is. And I covered that stuff too, so nothing amazing there. So first you extract the X and the Y coordinates from the L param. Then you check to see whether it's actually within the screen. So these X and Y coordinates are relative to the top left-hand corner of the client section. So we got to make sure that X is greater than 0, because if it's less than 0, that means it's outside the client region. So if it's inside the client region, which is what all these are saying, then we call mouse move, we update the position, and we also check to see whether if the current state of the mouse is not in the window, meaning before this message the mouse cursor was considered to be outside and it moved in the window, and if it moved in the window, we want to capture the mouse, which is a it's basically a set capture. We'll capture the mouse to our window, and it will allow us to receive messages about the mouse even if the mouse leaves the window, which is important, because if you want to know whether the mouse is in the window or outside the window, you have to get messages about the mouse when it leaves the window. So we set capture to get so that we can get messages for the mouse even if it's outside the client area of the window. And we call on mouse enter here to change the state of the mouse so that it's now inside the window. We want the server object to be aware that the mouse is inside the window now, so it has to keep track of that. But we only do that if the mouse was outside previously and just moved in. Now, if X is if the cursor is outside of the client area of the window, then we have some different we have two different cases here. If the mouse moved outside the client window, but there is still a button being pressed. See, W param, L param contains the coordinates of the mouse when on a mouse move. W param contains what mouse buttons are currently being held down. So if there is a mouse button being held down while we move outside the window, I've made the behavior of the mouse so that it should, how to say it, it should still register that the mouse is inside the window. So for example, say this is our window, and last time we got a mouse message, it registered here. Wait, that's kind of close. I don't want mess up my diagram. We registered here, and then we moved our mouse cursor here. So now our mouse cursor is over here. But if we're holding down the key, instead of it just registering as leaving the window, since the key is still being held down, the mouse button, it will register as being here. Likewise, if I move down to here, it'll register as being here. It'll register as being at the point closest to where it really is. And so it keeps the mouse there. So, because imagine you're doing like a drawing program or something and you want to draw at the edge of the screen. It's going to be really hard because you're going to move off the screen or something, or you want to... It's hard to explain, but when I was writing that drawing program, it was really hard to get to the very edge because you'd move off and you would be left with like a little gap. And by doing this, even if you held down the button and left the screen, it would still stay here and it would allow you to draw at the very edge. So basically, in order to get that behavior, I had to add this if statement here. And that's all it does. It checks to see if any buttons are being held down. So here it checks to see if we're outside the client area. And if we're outside the client area, we check to see if we have any buttons held down. And if we have buttons held down, then we modify the X and Y so that they're within the client area. And we call onMouseMove. But if there are no buttons being held down and we're outside the client, then we release the capture of the mouse. We stop receiving mouse messages for when the mouse is outside of the client area. That's what release capture does. And we update the server, the mouse server, so that it knows that the mouse has actually left the window. And we also release the left and right buttons in case they weren't properly released before in the state. It's hard to explain, but there can be a situation where this is false and yet the server still thinks that the buttons have been pressed. So we clear the state of the left and right buttons when we leave. And that's that. So it's a little complicated, but if you think about it, everything has a reason. And functions like release capture, set capture, they are in the API. You can look them up with Google. And same as if you look up mouse move, you can figure out the meaning of L param and W param, what kind of information they hold. W param is here. Yeah. So that's how I handled the mouse. And if you want a different behavior for the mouse, if you want it so that it stops giving mouse input as soon as you leave, even if the buttons are pressed down, you can just delete this part here and you'll get that behavior. Or if you want some other kind of behavior, you can also fix that. Yeah. Like for example, let me just give you an example. I'm going to start, no. So I'm running this program, it runs fine, right? Now, what happens if I resize the window? Oh, I can't. Ah, good. Never mind. I can't resize the window, and you know why I can't resize it? Because when I called create window, I didn't use overlapped window. I used caption, minimize box, sys menu. And what that does is that if you call create window with these three styles, you'll create a window which cannot be resized. It doesn't have resizing capability. And that's good because resizing the window in with the DirectX doesn't give you a very good effect unless you handle it specially. So yeah, I can't show you that thing that I wanted to show you. Too bad. Oh well. So yeah, and of course, because I have a keyboard server and a mouse server, I have to pass them both to the game constructor, because the game object now embeds, where is it? Game.h. The game object now embeds a keyboard client and a mouse client. So it needs a reference to the keyboard. Here, where is it? Where is my thing? game. Yeah, it needs a reference to the keyboard server and the mouse server. It takes these two references and it uses them to construct the keyboard client and the mouse client. And those keyboard clients and mouse clients, they hold the references to the servers and they provide the interface to the data which is stored in the servers. Yeah, alright, so that is all I want to say about Windows in the framework. The main thing, the heart of the Windows part is the message loop, or what we call the message pump, which just basically checks for messages and dispatches them, and the message procedure, which actually handles the messages. That's the heart of the whole thing. And this stuff is just initialization. And once it's processed all the messages, if there's no message, then it goes and runs your game. And yeah, that's the way it is. I don't know how difficult that seems to you guys, but it's not that complicated. There's just not really much to do here. I mean, the only thing for you guys to do is handle different kinds of messages in the message proc, right? Because there are tons of messages you could be handling. For example, you could handle the resize message and you could get it to do some useful shit. But besides that, there aren't too many messages you want to handle. Just keyboard and mouse, really. And we've already got that. I can't think of anything else on the top of my head. I don't think there are messages for gamepads. You need to use a special API to access a gamepad, like direct input or something like that. And you don't use messages for like networking or anything. You use special networking functions, WinSock and such. So it's mostly just for keyboard stuff. I'm sure there's something else, like for example, if you wanted to exit the game when you pressed escape, you could do something like this. So right now, we'll just go right now when I run my program and I press escape. Get out of the way. Nothing happens. I'm pressing escape right now. Nothing's happening. So let's say I want escape to be the end game thing. You can do that even without bothering to go to the game object. Mostly you want the game object to handle all your input and stuff like that. But for the case of something very functional, like a escape button or something like that, alt tabbing or something like that, you can handle it without even bothering the game object. All you do is you could go case vk escape and just call post quit message. Where's my 0? There it is. And then call break. Or you could call return, it doesn't matter. I'm not saying call break, but just break. You could return or you could break, it doesn't matter. And by posting the quit message on escape, that will cause the program to end whenever you press escape. Yes. Run. So here I am, and I'm going to press escape now, and program ended. That's just one example of how you can modify this message procedure to do something that it didn't do before. Now, what we are going to be doing later on is we're going to be modifying the keyboard system here, and with it we're going to modify this code here to make it a lot easier to get button presses, single button presses, and to get keyboard input, like typing in like a string of characters, like a name or something. Because right now it's really hard to do like that. It works almost like a gamepad with just a few key states. But when you want to get in on like strings of characters, individual button presses, it doesn't work too well. As if you remember from our tic-tac-toe game, we made like a little modification. We added something onto the end in our game object so that we could interpret these key presses as, or these key states as individual key presses. But it wasn't a perfect solution, and the better way to do it is to actually modify the keyboard object itself to handle these things a lot more elegantly. So we're going to handle that. We can also modify, for example, the mouse code here to, for example, if the user resizes the window, currently that just messes up the alignment of the mouse messages, but you can handle the mouse messages such that even if the window is resized, it still gives the proper coordinates to the game object or to the mouse server. And that just requires a simple modification in here. These are the kinds of things that you can do, but for the most part, you're not going to be fooling around with the Windows stuff too much. Like I said before, you can change the style of your window and stuff like that, but for the most part, not that important. But in order to make your own game from scratch, you need to be able to interface with Windows 32 at least a little bit, just like this. So that's why I'm explaining it. And now I have explained it, and I'm done explaining it. I've explained the windows, I've explained the keyboard, I've explained the mouse. The game is just basically lumps all that shit together. The game embeds a graphics object, a keyboard client, a mouse client, and a direct sound object. It embeds all these objects, so they all get created when the game is created, and then it handles all the logic of the game. And right now, we're not writing it very well because we're just writing we're putting all of our game data in the game object, and then all of our game functions, and all the functions can access all the data. And it's just a big incestuous orgy. But when we make our first real C++ game, we're going to be breaking the game system down into multiple different modules and classes, different objects, and they will only be able to access some of the data of their peers or of the objects that they contain. And so you won't have this big incestuous situation where all the functions can access all the data anytime they want. The access will be very restricted. And that will make it a little more difficult for us as programmers, but in the long run, it'll enable us to create more complicated systems that don't collapse under their own nastiness when they get too big, which is what basically what object-oriented programming is all about. But that is for the next lesson, because next lesson we're going to be starting an actual game project. I've mentioned it before on the forums and stuff like that, but we're going to have it's going to be a platformer, and it's going to have a lot of features like, I don't know, like scrolling and scripted events and shit like that, animation. It's going to be a side view platformer with combat and shit. I haven't decided all the details yet, but I'm getting some stuff in my head. But the main thing is it's going to be all out in C++. So all object oriented, and it's going to be a lot better programming style than what we've been doing up until now. So hopefully you guys will learn a lot. That intermediate lesson 1, where I gave you a little bit of an introduction to classes, that wasn't meant to be like, I don't know, like a comprehensive lesson on classes. That was just a little hint, basically. So I won't be assuming now that you know everything about classes. I'll be taking it fairly slow as I introduce new topics or review topics that were covered in that lesson. So if you're worried that you didn't get, enough knowledge about object-oriented programming from intermediate lesson 1, don't worry about it. It wasn't intended to really make you confident in using classes. It was just meant to give you a little bit of a view of how a class could be used to solve a problem in programming. And now we're going to be making way more, and I'll be explaining way more. And it's going to be an actual game, because we haven't actually made a real game type deal since the tic-tac-toe game. So I've just been busy, explaining all these topics, because everyone keeps like pestering me about, I want to be able to draw sprites, and I want to know how DirectX works. So I haven't been able to get to making an actual game. And now we can actually do it. So, and it's going to take quite a few lessons. I think it's probably going to be like, I don't know how many lessons it's going to take, because it's going to be way bigger than like the Pooh game. The Pooh game was like 1.5 hours maybe to make it. This thing is going to be a lot more complicated. We're going to be doing a lot more shit. But we'll be building it up part by part, and I'll be taking you guys through a journey of going from nothing to basically a pretty decent game engine. So look forward to that in the coming weeks and months even, because it's the whole game, the project's probably going to stretch over a couple months at least. So we're going to make a game. Look forward to that. But for now, my throat is really sore and it's dark. I didn't even turn the lights on yet. I think it's time to go. It's time to mosey on down and I think play some tennis. So I'll see you guys when I see you guys.